Hello everyone, welcome to our online class. In today's class, we'll start with a new unit, another unit. It is what calculus. For JNT students in M-1 it is in unit 4, and for OU students it is in unit 2. Right? In calculus, what topics we have? First of all, mean value theorems. It was there. Correct. So in mean value theorems, how many theorems we have? We have first one Rolle's theorem. Correct. First one is what? Rolle's theorem. Second one is what? Lagrange's mean value theorem. Correct ma? Lagrange's. Third one is what? Cauchy's mean value theorem. And after that we have Taylor series expansion. Correct? Taylor series expansion we have. So from these four topics you get one question. Then after that we have multiple integrals. Correct? So applications of integrations is there. So applications of definite integrals are there. In that you have evaluate surface areas and volumes. Correct? That is one topic is there. So this is one topic. Then integration applications, integrations one topic, and improper integrals are there. Correct? Improper integrals. I already completed improper integrals video ma. Please go through that, beta and gamma functions. Then we'll do this topic. After that we'll see this integrating and all. Right? So first one. Mean value theorems. How many mean value theorems we have? We have 3 mean value theorems. Correct. In that, first one is what? Rolle's theorem. What is the first one, ma? What is the statement? First one is what? Rolle's theorem. Correct. So we solve quickly, ma. Rolle's theorem. We'll see the definition of Rolle's theorem. I think it's a small definition, right? Very important. It will come for 2 marks, ma. So Rolle's theorem definition. What is Rolle's theorem definition? Let f of x be any function, correct? Let f of x be any function, such that what is the first point? F of x is continuous. It should be f of x is continuous in closed interval a comma b, correct? Second point is what? F of x is differentiable. F of x is differentiable or derivable, right? F of x is differentiable in open a comma b. Then what is third point? F of a is equal to f of b. What is third point? F of a is equal to f of b. If these 3 conditions are verified, then there exists symbol ma, there exists C belongs to a comma b such that f dash of c is equal to 0. Then there exists at least one point C in open interval a comma b such that C belongs to a comma b such that f dash of c is equal to 0. This is a statement of Rolle's theorem. Correct? So what is the next one we have? Geometrical application interpretations are there, that will you go through it ma from the textbook. So next one, what is the next theorem we have? We have Lagrange's mean value theorem. Correct? Next one is what? Lagrange's, whatever you call it. Lagrange's mean value theorem, MVT. Lagrange's mean value theorem. What is the definition of Lagrange's mean value theorem? Let f of x be any function. Let f of x be any function such that first point is what? First 2 points of Rolle's theorem and Lagrange's theorem are same. F of x is continuous in closed interval a comma b. Second point, f of x is derivable or differentiable in open a comma b. F of x is differentiable in open a comma b. Then there exist only 2 conditions here. Then there exists C belongs to a comma b such that f dash of c is equal to f of b minus f of a by b minus b. Correct? So this is the definition of Lagrange's mean value. Then what is Cauchy's? Cauchy's may we have 2 functions. No, Cauchy's mean value theorem we have how many functions? We have 2 functions in Cauchy's mean value theorem. Then third one is what? Cauchy's. See, Cauchy's mean value theorem. Here what you have to take? Let f of x and g of x. F of x and g of x are 2 functions. Such that what is the first point ma? F of x and g of x are continuous in closed interval a comma b, correct. Then what is the second point? F of x and second point, f of x and g of x are derivable or differentiable in open a comma b. Here what is the third condition? G dash of x is not equal to 0. G dash of x is not equal to 0. Then there exists c belongs to a comma b such that what is the condition here? F dash of c by g dash of c is equal f of b minus f of a by g of b minus g of a, correct. So short answers, if it is there, short answers will come 2 marks. So luckily in now in current exam we don't have short answers for JNTU. For OU students are there, it will come for short answer for 2 marks. Definition he will ask you, right. So this is the Rolle's theorem definition. These are the definitions of Rolle's theorem, Lagrange's mean value theorem and Cauchy's mean value theorem. Understand here, in calculus we have 3 topics. First one is what? Mean value theorems. Second one is what? Applications of integrations, definite integrals. Second up what? Definite applications of definite integrals to evaluate surface areas and volumes. Those all are. Third one is what? Improper integrals, correct. So now we started with the Rolle's theorem, mean value theorems topic, right. So let us solve the problems, previous year question papers problems on these 3 theorems, okay. So we solve simultaneously these 3 problems. Otherwise first we finished off Rolle's theorem problems, then we will do Lagrange's, then we will see Cauchy's, okay. So first let us start with the Rolle's theorem problems. See the first problem. Verify Rolle's theorem for the function f of x is equal to sin x by e power x in closed interval 0 comma pi, 0 comma pi, okay. So how to solve this problem? Solution, first what we have to do, f of x given can be written as, see here, given f of x is equal to, this e power x can be taken into numerator, e power minus x into sin x. Can I write like this? Yes, we can write, correct. Now what I am doing here, I am calculating f dash of x. I am calculating here f dash of x. What is my f dash of x here? UV method, no, e power minus x into sin x differentiation cos x. Sin x differentiation is what? Cos x plus sin x into e power minus x differentiation is what? Minus e power minus x. E power minus x differentiation is what? Minus e power minus x. I calculated f dash of x value. Now see here, what is the first point? f of x is continuous. F of x is, what do you have to write, ma? F of x is continuous function in closed interval 0 comma pi, since it is a exponential and trigonometric function. Second point, what you have to write? F of x is differentiable. F of x is differentiable in open 0 comma pi. F of x is differentiable in open 0 comma pi. Then third point is what? You need to verify f of a. What is a value here? 0. What is b value here? Pi. What is a value? 0. What is b value? Pi. F of a, that means f of 0 is equal to, in place of x you have to write 0, ma. E power 0 into sin 0. Sin 0 is 0. 0. F of b, that means f of pi, correct. E power pi minus pi into sin pi. Sin 180 is what? 0. Sin 180 is what? 0. That means you got f of a is equal to f of b. This implies f of 0 is equal to f of pi, correct. Now what happened here? All conditions of Rolle's theorem are verified. All conditions of Rolle's theorem are verified. Then what we have to do, ma? Then there exists c belongs to 0 comma pi such that f dash of c is equal to 0. Such that f dash of c is equal to 0. Now what is f dash of x? We already calculated. So what is f dash of c here? This implies f dash of c is what? E power minus c into cos c plus sin c into minus e power minus c is equal to 0. Take this term that side. What it become? E power minus c into cos c is equal to sin c into, this minus will go that side, become plus e power minus c get cancelled, ma. Cross multiply this sin c cos c that side, sin c by cos c. Sin c by cos c is how much? Sin c by cos c is how much? Tan c is equal to 1. Tan 1 when we get in tan pi by 4, tan got cancelled, c is equal to pi by 4 belongs to 0 comma pi. So pi by 4 will be there in 0 comma pi, no? Yes. So like that, c is belongs to 0 comma pi. Like this, you need to solve this Rolle's theorem. Understand here how we did this problem on Rolle's theorem. First one is what? First you need to verify whether it is continuous or derivable and these 3 points are satisfying or not. From these 3 points, if any one point is fails, then Rolle's theorem is not applicable. Understand here? Rolle's theorem is not applicable. So first word, this is the exponential function and a trigonometric. So it is continuous in closed interval 0 comma pi. So when it is discontinuous, when 1 by x square, those type of things are given. If the interval in between the interval 0 is there, in those type of situations you have. Suppose if it is a tan x, 0 comma pi mein pi by 2 is there. Tan x is what? Tan 90 infinity, right? So that is a discontinuous. Those type of sums we have to be very careful, right? So first one, f of x is equal to what? This can be written as e power minus x into sin x. F of x is continuous, differentiable. Then you need to check f of a is equal to f of b. If these 3 conditions are verified, you can write one point here. All conditions of Rolle's theorem are verified. Like that you can write. Then you need to calculate the c value. So f dash of c is equal to 0. Already we calculated f dash of x, substituted f dash of c e power minus c cos c plus sin c into e power sin c into minus e power minus c. Take this side, cancel it, you got the answer. Understand? We solve another problem. Next problem, similar problem. Verify Rolle's theorem for the function f of x is equal to e power x into sin x minus cos x into in pi by 4 comma 5 pi by 4. So first point is what? This is f of x given. So first you can write simply f of x is continuous in closed interval pi by 4 comma 5 pi by 4. Write full ma. Okay. So second point is what? F of x is differentiable or derivable in pi by 4 comma 5 pi by 4, right? Then third point, f of a, right? F of a means how much here? F of pi by 4. F of pi by 4 e power pi by 4 sin pi by 4 minus cos pi by 4. Cos sin pi by 4 is how much? 1 by root 2. Cos pi by 4 is how much? 1 by root 2. So e power pi by 4 into 1 by root 2 minus 1 by root 2 will give you 0. Pi by 4 is what? 45, no? Okay. Pi by 4 is 45, no? Okay. Next, f of b. F of b means f of 5 pi by 4. F of 5 pi by 4 e power 5 pi by 4 sin 5 pi by 4 minus cos 5 pi by 4. Okay. So sin 225 is minus 1 by root 2. Minus 1 by root 2. This is also minus. Minus of minus plus. So both will get cancelled, you get 0. So, right. So 3 conditions are verified. So all conditions. Therefore, here f of a is equal to f of b, no? F of a is equal to f of 5 pi by 4. All conditions of Rolle's theorem are verified. Correct. So what you have to write? Then there exists c belongs to pi by 4 comma 5 pi by 4 such that f dash of c is equal to 0. Correct. So what is our f dash of c here? F dash of c, this one, how to differentiate? UV method, no? UV method. See, this implies e power c into sin c differentiation cos c minus cos c differentiation minus c ma. Correct? Minus of minus plus c into sin c minus cos c e power c differentiation e power c only. Correct? E power c differentiation is what? E power c only. UV method I did, right? So from these two terms, if I take e power c common, what I get here? Cos c plus sin c minus cos c is equal to 0. So cos c got cancelled. Cos c and cos c got cancelled, right? So therefore, what I get here? Sin c, 2 sin c into e power c is equal to 0. So this cross multiply, this is sin c is equal to 0. When it is 0 ma, sin pi, sin got cancelled, c is equal to pi. When it is 0, sin 180 is 0, no? Sin 180 is 0. So c is equal to pi belongs to pi by 4 comma 5 pi by 4. Pi by 4 comma. Like this, you need to solve this problem. So differentiation. So simple topic it is what? If you know how to derive f dash of x, f dash of c is simple. These three conditions are the same for all the problems. Continuous differentiation. Only thing is when it is 1 by x square, in those cases you have to be very careful. Okay. Okay. Next problem. Next problem. F of x is equal to x square plus 3x into e power minus x by 2. So write in closed interval minus 3 comma 0. So what we have to do, first of all, f of x is continuous in closed interval minus 3 comma 0. Second point, f of x is, what is f of x ma? F of x is derivable, correct, or differentiable in open minus 3 comma 0. Now what you have to find f of a. What is f of a? F of minus 3. If I substitute minus 3 here, 9 minus 9 e power 3 by 2. 9 minus 9, 0. Then f of b. F of b, a value minus 3, b value 0, no? F of 0 is what? 0 plus 0, e power 0. 0 into anything is what? 0. Correct? So this implies what happened here? F of 0 is equal to f of minus 3, or anyhow f of minus 3 is equal to f of 0. All conditions of Rolle's theorem are verified. What we have to do now? Then there exists c belongs to minus 3 comma 0 such that f dash of c is equal to 0. What is f dash of c here? UV method, no? So in place of x you have to write c here first of all. C square plus 3c into e power minus c by 2 differentiation is what? E power minus c by 2 into chain rule differentiation of minus c by 2 is how much ma? Minus 1 by 2 plus e power minus c by 2 into c square differentiation 3c plus 2c plus 3. Sorry ma, c square is 2c, no? Correct. So e power minus c by 2 take out common and send that side, it will get 0. Correct. Otherwise, one second. Otherwise, take this term that side. What happened here? So c square plus 3c into e power minus c by 2 into minus 1 by 2 is equal minus e power minus c by 2 2c plus 3. So e power minus c by 2, e power minus c by 2 cancel. This minus and minus get cancelled. This 2 will cross multiply. C square 4c will come this side, minus 4c. 2 3s are 6, 6 plus 3. Correct? 2 3s are 6, no? 6 plus 3. So how much it is? How much will get here? Minus 4c, no ma? 4 will come this side, minus c, minus 6 is equal to 0. Correct? Minus is equal to 0. Now we need to calculate it. Take the calculator and calculate the roots ma. Here minus c or plus c. Take the calculator and find out the c values ma. C value, how to write? So c square minus 3c plus 2c minus 6 is equal to 0. So c minus 3 into c plus 2. So c is equal to 3, c is equal to minus 2. This belongs to minus 3 comma 0. Correct? Belongs to minus 3 comma 3. Like this, you need to solve this problem. Understand here how we did this problem? Okay? 3 comma minus 2. Right. Next problem. Okay. Next problem. Verify Rolle's theorem for the function f of x is equal to, verify Rolle's theorem for the function f of x is equal to log of x square plus ab by x into a plus b in closed interval a comma b. Okay. So I am explaining very the all important problems only ma. Okay. So go through these all problems, practice these all problems. So first one is what? F of x is continuous in closed interval a comma b. F of x is derivable in open a comma b. Then third point, f of a is what? Log of a square plus ab by a into a plus b ma. Correct? So if I multiply a square plus ab, you will get 1. Correct? Then log f of b is what? Log of b square plus ab by b into a plus b. So if I multiply, I will get 1. So that means f of a is equal to f of b. F of a is equal to what? F of b. Right? Now here one small step. Okay. So now see, then all conditions of Rolle's theorem are verified. Then there exists c belongs to a comma b such that f dash of c is equal to 0. So first what I am doing here, I am writing like this. F of c is equal to, this is log a by b formula, no ma? Log a by b formula can be written as log a minus log b. Like this I wrote. Okay, how we took this formula? Log a by b is equal to log a by b is equal to log a minus log b. So in place of x I substituted c. F of c is equal log a minus log b I wrote. Now f dash of c we need, right? So differentiation of log x is what? 1 by x, 1 by c square plus ab. Again chain rule differentiation of this c square is 2c minus, again here log x differentiation is what? 1 by x, c into a plus b. Chain rule differentiation of this c is 1, I will get here a plus b is equal to 0. A plus b got cancelled ma. So 2c by c square plus ab is equal to this minus 1 by c, bring this side, it get plus 1 by c. Cross multiply, 2c square is equal to c square plus ab. 2c square is equal to how much ma? C square plus ab. So this implies, so c square will come this side, c square, 2c square minus c square is equal to ab. C is equal square root of ab belongs to a comma b, belongs to a comma. Like this you need to solve this problem. Understand here? So log a by b can be written as log a minus log b. Like this you need to solve this problem. Very, very important problem. C belongs to a comma b, we prove, right? Next problem. Next problem. Verify Rolle's theorem for the function f of x is equal to x minus a whole power m into x minus b whole power n. X minus a whole power n into x minus b whole power n in closed interval a comma b. Here m and n are positive integers ma. M and n are positive integers. So first point is what? Given you write down f of x. F of x is continuous in a closed interval a comma b. F of x is derivable in open a comma b. Then third point is what? F of a, no? If I substitute here a, what I get here? A minus a whole power m, a minus b whole power n. A minus a is how much ma? 0. So f of b, b minus a whole power n, b minus b whole power n, it is what? 0. That means f of a is equal to f of b. All conditions of Rolle's theorem are verified. All conditions of Rolle's theorem are verified. Then what we have to do now? Then there exists c belongs to a comma b such that f dash of c is equal to 0, right? So what is f dash of c here? First f of c is what? C minus a whole power m into c minus b whole power n, right? So UV method. So f dash c minus a whole power m into c, if I differentiate this part, n into c minus b whole power n minus 1. Chain rule differentiation of this part is 1 ma, plus c minus b whole power n into differentiation of this part is what? M into c minus a whole power m minus 1 is equal to 0. First what we have to do? F of c you have to calculate. What is f of c here? In place of x you have to write c. After that you need to differentiate ma. Now see here, this plus term, no, take that side, c minus a whole power m into n, c minus b whole power n, power minus 1 is there, no, can be written as c minus b is equal, this plus will go that side, minus c minus b whole power n into m, c minus a whole power m by c minus a. C minus b whole power n, this part get cancelled, this part got cancelled, correct? Now if I cross multiply, what is left here? If I cross multiply, nc minus an is equal to minus mc plus bm. We need which value we need? We need c value, right? We need c value. 1 second. So take this term this side ma. nc plus mc is equal to, this term will come this side, an plus bm. An plus bm. Now take out c common, m plus n is equal to an plus bm. So c is equal to what? An plus bm by m plus n belongs to a comma b. Belongs to a comma b. Like this you need to solve this problem using Rolle's theorem. Using Rolle's theorem. Understand? Okay, we will solve another problem. Okay. Next problem, verify Rolle's theorem for the function f of x is equal to x plus 2 whole cube into x minus 3 whole power 4 in closed interval minus 2 comma 3. Correct? So what is the first point? Write down f of x, then f of x is continuous, since it is a polynomial, minus 2 comma 3, f of x is derivable, minus 2 comma 3, f of a, that means a value is how much ma? Minus 2. If I write minus 2 here, minus 2 plus 2 minus 2 minus 3 whole power 4. Minus 2 plus 2 is what? 0. Then f of b. What is f of b? B value is how much? 3. 3 plus 2 whole cube. 3 minus 3 whole power 4. 3 minus 3 is what? 0. So f of minus 2 is equal to f of 3. Correct? F of minus 2 is equal to f of 3. So all conditions of Rolle's theorem are verified. Then there exists C belongs to minus 2 comma 3 such that f dash of c is equal to 0. What is f dash of c? UV method, no. C plus 2 whole cube into differentiation of this part is what? 4 into c minus 3 whole cube plus c minus 3 whole power 4 into differentiation of this part is what? 3 into c plus 2 whole square mark is equal to 0. UV I did, correct? So this term take that side, c plus 2 whole cube into 4 into c minus 3 whole cube is equal minus c minus 3 whole power 4 3 into c plus 2 whole square. So c plus 2 whole square, this 3 get cancelled, whole cube, this 4 get cancelled. What is left here? Here 4c, 4 to the 8 is left, here minus 3c plus 9 is left. So c, one second ma. So this will come this side, 7c is equal to 1, 7c is equal to 1, c is equal to 1 by 7 belongs to minus 2 comma 3. Okay, understand? Like this you need to solve this problem. Okay, these all problems all three conditions are verifying. Now when this Rolle's theorem is not applicable, see those problems, we will solve that problem. See here, verify Rolle's theorem for the function f of x is equal to 1 by x square in minus 1 comma 1. So what happened here in minus 1 comma 1? In between minus 1 comma 1 you have 0. If I substitute 0 here in place of x, what happened ma? You get, what happened here? You get infinity. So in this type of problems, here f of x is equal to 1 by x square is discontinuous, correct? Discontinuous at x is equal to 0. At x is equal to 0. If it is discontinuous, what happened here? All conditions of Rolle's theorem are not verified. All conditions of here, what happened here? F of x is 1 by x square is discontinuous at x is equal to 0. Because if I substitute x is equal to 0, what happened here? Anything by 0, infinity we get ma, correct? We get infinity, So it is a discontinuous. So all conditions of Rolle's theorem are not verified. Rolle's theorem is not applicable. Understand here? Rolle's theorem is not applied or not applicable. Like this you need to verify. Understand? 1 by x square. Similarly, we have one more problem. F of x is equal to tan x. F of x is equal to tan x in closed interval 0 comma pi. In 0 comma pi, 90 degrees is we have. 0 comma pi we have 90 degrees. So tan 90 is what? Infinity, no. So f of x is equal to tan x is discontinuous, correct? Discontinuous at x is equal to pi by 2. At x is equal to pi by 2. So therefore Rolle's theorem is not applicable. So therefore Rolle's theorem is not applicable. Understand here? So like this you need to verify whether Rolle's theorem is applicable or not. Okay, next. Understood? Next problem, f of x is equal to x square in closed interval 1 comma 3 ma. See here what happened? First point, f of x is continuous in closed interval 1 comma 3, correct? Then second point, f of x is derivable. F of x is derivable in open 1 comma 3. Then third point, what is f of a here? A is 1, no. F of 1, that means 1 square is what? 1. F of b is how much ma? F of 3. F of b is how much? F of 3. 3 square is how much? 9. So what happened here? F of 1 is not equal to f of 3. So therefore all conditions of Rolle's theorem are not verified. Rolle's theorem is not applied or not applicable. Like this you need to solve these type of problems. Understand here? So these three problems are not applicable problems. Okay, so when this Rolle's theorem is applicable, when these three conditions are verified. Understand? Like this, you need to solve this Rolle's theorem. Okay, so we have one more problem. We will solve another. Next, very important problem. F of x is equal to mod x. Verify Rolle's theorem for the function f of x is equal to mod x in closed interval minus comma 1 comma 1. What happened here? Given f of x is equal to mod x. Correct? Here, what happened? F of x is equal to x when x is greater than or equal to 0. Correct? Then f of x is equal to minus x when x is less than 0. When mod is what? When it is greater than or equal to 0, it is positive. When it is less than or equal to 0, it is negative. Right? Now, here first point is what? F of x is continuous, right? In closed interval minus 1 comma 1. Mod is there, so it is continuous. Now, when it come to derivable, what happened here? F of x is not derivable. See, why? Because, so f of x is not derivable at x is equal to 0, right? Why? See here, first of all, calculate right hand side limit. F dash of 0, right hand side limit, f dash of 0 is equal to what? Limit x tends to 0 plus, mein what this f of x becomes positive, no? X minus 0 by x minus 0. Correct? F of x minus 0 by x minus 0. That means f of x is what? Mod x, no? You get 1. You get here 1. Then similarly, in f dash of 0, this is what? Right hand side limit, right hand side derivative. If it is left hand side derivative, f dash of 0, limit x tends to 0 minus, what happened here? You get minus x minus 0 by x minus 0. Correct? So this will give you minus x by x, that means minus 1. Minus x by x, it is what? Minus 1. So right hand side derivative, it is plus 1. Left hand side derivative, we got minus 1. So therefore, right hand side derivative is not equal to left hand side. That means left hand side LHD is not equal to RHD, right hand side derivative. So therefore, f of x is not derivable at x is equal to 0. So therefore, f of x is not derivable at x is equal to 0. Limit you have to calculate, no? So therefore, Rolle's theorem is not applied. Like this, you have to solve this problem. Very important problem. It is continuous in minus 1 comma 1, but it is not derivable in minus 1 comma derivable in the interval at minus 1 comma 1. Understand this problem? Okay, we'll start another. Now we'll go for next problem. Okay, next one, verify Lagrange's mean value theorem. Right. So Rolle's theorem problems we completed, few problems. Now we'll start Lagrange's mean value theorem. So verify Lagrange's mean value theorem for f of x is equal to x into x minus 2, x minus 3 in closed interval 0 comma 4. Correct. So similarly, first what happened here? F of x given, write down given f of x is equal to, multiply these two things. What I get here? X into x square minus 3x minus 2x minus 5x plus 6. That means x cube minus 5x square plus 6x. X cube minus 5x square plus 6x we got. Right. So what is the first point? We have to write f of x is continuous since it is a polynomial function, right? X is okay. So therefore, first point f of x is continuous in closed interval 0 comma 4. F of x is continuous in closed interval 0 comma 4. Second point, f of x is derivable. F of x is derivable in open 0 comma 4. Correct? Now then there exists c belongs to 0 comma 4 such that f dash of c is equal to what? F of b minus f of a by b minus a. That means what is our b value here? 4. What is our a value here? 0 by 4 minus 0. Correct? What is f dash of c ma? So 3c square minus 10c plus 6 is equal to f of 4. If I substitute 4 here, 4 into 4 minus 2, 8, I get 8 minus f of 0. 0 into anything is what? 0 by 4. So 8 by 4 I get 2. Take this 2 this side. 3c square minus 10c plus 4 is equal to 6 minus 2, 4. Correct. So f of 4 understood, no? Here 4 you have to write, or you can write 4 here also, no problem. F of 0, f of 0, right? So now take the calculator and solve it. Using calculator, I got the values as c is equal to 5 plus root 13 by 3 is one value, approximately 2.87. C is equal to 5 minus root 13 by 3, approximately 0.46. So these both values belongs to 0 comma 4. Both values belongs to 0 comma 4. Hence Rolle's theorem is verified. Like this you need to solve this Lagrange's mean value theorem, not Rolle's theorem, Lagrange's mean value theorem. Okay. So next problem. Okay. Okay, next very important problem. I think this problem you already know all. Why? Because they'll teach you in college. It's a very important problem, right? If a is less than b, prove that b minus a by 1 plus b square is less than tan inverse b minus tan inverse a is less than b minus a by 1 plus a square, using LMVT, Lagrange's mean value theorem, and you need to derive these conditions. Okay. So first, how to solve this one? Here he is not given the function, right? So what we have to do? Let f of x is equal to tan inverse x. What is the interval here? Closed interval a comma b. And interval what we have to do, ma? Closed interval a comma b. A is less than b, so we took interval a comma b. Now what is first point here? F of x is continuous in closed interval a comma b. This is first point. Second point, f of x is derivable, correct? Derivable in open a comma b, correct? F of x is derivable in open a comma b. Now okay, one second. Now what is the condition, ma? Then there exists c belongs to a comma b such that f dash of c is equal to f of b minus f of a by b minus a, correct? Now what is f dash of c, ma? So f of x is tan inverse x. F dash of f of c is what? Tan inverse c. This differentiation of tan inverse is what? 1 by 1 plus x square, means in place of x you have to write c. 1 by 1 plus c square is equal to f of b, tan inverse b minus f of a, tan inverse a by b minus a, correct? B minus a. This is marked as question number 1. Marked as question number 1. Okay. So now actually what you have to prove here, you have to find c belongs to you need to show c belongs to a comma b, correct? So c belongs to a comma b. That means see, this is actually a little bit big problem. So we know what you have to write. We know that, or we have, you can write, we have c belongs to a comma b. We know that we have to prove that c belongs to a comma b. So how to write this one? Okay, I'll write here. So c belongs to a comma b. We have a is less than c is less than b, correct? We have a is less than c, c is less than b. Now convert this part into 1 by 1 plus c square. How to convert? Squaring on both. A square is less than c square is less than b square. Add 1 plus a square is less than 1 plus c square is less than 1 plus b square. And take reciprocal. 1 by 1 plus a square is greater than 1 by 1 plus c square is greater than 1 by 1 plus b square. That means, so this is the smallest one. 1 by 1 plus b square is less than, what is this value, ma? Tan inverse b minus tan inverse a by b minus a, correct? Is less than 1 by 1 plus a square. Okay, is less than 1 by 1 plus a square. That is the proof, no? So this is the proof. See this problem, correct? This is the proof of the problem. 1 by, oh sorry, we have one more step. To cross multiply this b minus a. B minus a by 1 plus b square is less than tan inverse b minus tan inverse a is less than b minus a by 1 plus a square, correct? This is the proof. Understand? Now you need to derive these two conditions. How to derive these two conditions? Understand here what we did. First we took f of x is equal to tan inverse x, then it is continuous, it is derivable, then there exists c belongs to a comma b, f dash of x, this differentiation 1 by 1 plus x square, in place of x we took c value. So tan inverse b minus tan inverse a by b minus c I substituted. So actually we have c belongs to a comma b, a is less than c, c is less than b. You need to convert this part in this form by squaring, adding 1, then reciprocal, then substituting this 1 by 1 plus c square value. After that multiply both sides by b minus a. Clear? That is the solution. Now what you have to do, you need to deduce these values, right? You need to deduce these values. How to deduce these values? To deduce the first one, where will solve? I will solve that side. Okay, 1 second. So to deduce this first one, what we have to do here, this one marked as equation number 2 here, let a is equal to 1 and b is equal to 4 by 3. A is equal to 1 and b is equal to 4 by 3. How to remember this? Here b, this value is there, no? This is middle value 4 by 3. Both sides pi by 4 is there. Tan 45 is how much 1. So when you substitute 1, you get pi by 4. So like that you need to remember. A is equal to 1 and b is equal to pi by 4. If I substitute here you need to substitute b value 4 by 3 and a is equal to 1. What I get here? From 2, 4 by 3 minus 1 by 1 plus 16 by 9 is less than tan inverse 4 by 3 minus tan inverse 1 is less than 4 by 3 minus 1 by 1 plus 1 by 1 plus 1 square. So 4 by 3 minus 1 is how much 1 by 3. Here 9 plus 16, 25 by 9 is less than tan inverse 4 by 3. Tan inverse of 1 is how much? Pi by 4. So 1 by 3 by 2. 9 will go to numerator. 3 by 3 ones are 3 3 0, no? 3 by 25. This minus pi by 4 will come this side. Plus pi by 4 is less than tan inverse 4 by 3 is less than, add 1 by 6 plus 5 by 4. Understand? Like this. This is the first bit, no? Pi by 4 plus 3 by 25 is less than tan inverse 4 by 3 is less than 1 by 6 plus 5 by 4. Like this you need to solve. For second bit, what we have to do? For second bit, see here what is there here? 2 is there, no? So let b is equal to 2 and a is equal to 1 for second bit. Okay. So second bit, let a is equal to 1 and b is equal to 2. A is equal to 1 and b is equal to 2. What I get here? 2 minus 1, 1 by 1 plus 4, 5 is less than tan inverse 2 minus tan inverse 1 is less than 2 minus 1, 1 by 2. So tan inverse 1 is what? Pi by 4, no? This will come this side. So pi by 4 plus 1 by 5 is less than tan inverse 2 is less than pi by 4 plus 1 by 2. So take the LCM here. 5 pi plus 4 by 20 is less than tan inverse 2 is less than, LCM is what? 4, pi plus 2 by 4. Like this you need to verify these two bits verify these two bits. Understand here? So it's a little bit big problem, so that's what this board is insufficient. So like this you need to solve these problems. First case you have to substitute a is equal to 1 and b is equal to 4 by 3. To deduce the second bit you need to substitute a is equal to 1 and b is equal to 2 here. Okay, fine. Next problem. Next problem, show that 1 plus x is less than e power x is less than 1 plus x e power x for x greater than 0. To solve this problem, what we have to do here, let f of x is equal to e power x in closed interval 0 comma x. F of x is a function e power x defined in closed interval 0 comma x. So what is first point? F of x is continuous in closed interval 0 comma x. Second point is what? F of x is derivable, correct ma? Derivable in open 0 comma x. Write full continuous, okay? Don't write like just. Then there exists c belongs to 0 comma x such that f dash of c is equal to f of b. What is f of b? F of x minus f of a. What is f of a? 0 by x minus 0. What is f dash of c ma? F of c is what? E power c. F dash of c e power c is equal to f of x is what? E power x minus f of 0 is what? E power 0 by x minus 0. So this will give you e power x. E power 0 is 1 by x. Correct? So this one, take it, mark it as 1. Mark it as 1. What you have to prove actually? We have what we have? Um, we have a is less than c is less than b. We have a is less than c is less than b. Correct? Now see here, take e power a. E power a is what is a here? A is 0, no? 0. And what is b here? X. So e power 0 is less than e power c is less than e power x. Correct? E power 0 is less than e power c is less than e power x. E power 0 is how much? 1 is less than e power c. What is e power c value? E power x minus 1 by x is less than e power x. Correct? So multiply both by x. X is less than e power x minus 1 is less than e power x. Correct, ma? Now add 1. So if I add 1 plus x is less than e power x is less than, oh here you have to multiply by x, no? X will come less than 1 plus x into this only you need to prove. This only you need to prove, no? See here, this only you need to prove. Correct? 1 plus x. So this is important. We have 0 is less than c is less than x. Take e power 0 is less than e power c is less than e power x. E power 0 is 1. E power c value is what? E power x minus 1 by x. Multiply by x. Division x cancel. X e power x. Then add 1. You get the answer. That's it. Understand here? Okay. Okay. Next problem. Verify Lagrange's mean value theorem for f of x is equal to e power x in closed interval 0, 1. Right? So first solution, how to solve, ma? Given f of x is equal e power x. What is interval here? 0, 1. So what is the first point? F of x is continuous in closed interval 0, 1 since it is a exponential function. And second one, f of x is derivable. F of x is derivable in open 0, 1. Okay. So then there exists c belongs to 0, 1 such that f dash of c is equal to f of b minus f of a by b minus a. What is f dash of c? E power c differentiation, e power c only. What is f of 1, ma? E power 1. F of 0, e power 0 by 1 minus a. So e power c is equal to what? E power 1 minus e power 1 minus e power 0 is how much? 1. Correct? So I need c value. When e will go this side, it become log of e minus 1. So e is what? Lies between 2 and 3. So log of 2.7 something, right? So belongs to 0, so log of 2.7 minus 1 will give you 1.7. Log of 1.7 value lies between 0, 1 only. Okay? So like this you need to solve this problem. Okay? So now we'll stop here and we'll go for Cauchy's mean value theorem problems. Okay, ma. See the Cauchy's mean value theorem. So first one, verify Cauchy's mean value theorem for f of x is equal to x square and g of x is equal to x cube in closed interval 1, 2. Okay. So solution here, two functions, no? So what is the first point? So write down this given and all, ma. Okay, I'll write given f of x is equal to x square and g of x is equal to x cube. Interval is what? 1, 2. Right? So what is the first point? F of x and g of x are continuous in closed interval 1, 2. Correct? Then what is second point? F of x and g of x are derivable. Correct? Derivable in open 1, 2. Now third point is what? G dash of x. What is g dash of x? X cube differentiation 3x square is not equal to 0. Correct, ma? G dash of x is what? 3x square is not equal to 0. So all conditions of Rolle's theorem are all conditions of Cauchy's mean value theorem are verified. So then there exists c belongs to 1, 2 such that f dash of c by g dash of c is equal to f of b. Correct? What is f of b? F of 2 minus f of 1 by g of 2 minus g of 1. G of 2 minus g of 1. Correct? So what is your f dash of c here? 1 second, ma. what is your f dash of c here? F of x is x square, f of c is c square. So c square differentiation 2c, g dash of c is what? 3c square is equal to f of 2, how much ma? 4, f of 1 is 1, g of 2 is what? 8 minus 1. So c and get cancel, 2 by 3c is equal to 3 by 7, 3 by 7, cross multiply, 14c is equal to 9, this implies c is equal to one second, 14 is equal to 9c, c is equal 14 by 9, belongs to 1 comma, correct? 14 is equal to 9c, c is equal 14 by 9. Like this you need to solve this Cauchy's mean value theorem. Okay, next problem, next problem, f of x is equal 1 by x square, g of x is equal 1 by x in closed interval a comma b. So what is given here? F of x is 1 by x square and g of x is 1 by x. So f of x and g of x are continuous in closed interval a comma b. F of x and g of x are derivable in a comma b. What is g dash of x ma? 1 by x differentiation minus 1 by x square is not equal to 0. Correct. So then there exists c belongs to a comma b such that f dash of c by g dash of c is equal to f of b minus f of a by g of b minus g of a. Correct. So what is f dash of c here? What is f of c? F of c is 1 by c square. F dash of c 1 by c square differentiation minus 2 by c cube ma, minus 2 by c cube. Then g dash of x is what? 1 by x differentiation minus 1 by c square. F of b is what? 1 by b square. F of a is what? 1 by a square. G of b 1 by b and f of g of a is what? 1 by a. Okay. So now see here how to simplify this part. So therefore if I take LCM here, a square minus b square by a square, b square is LCM, divided by here LCM is what? AB, a minus b, correct? So 1ab got cancelled. A square minus b square can be written as a plus b into a minus b by ab into a minus b. A minus b got cancelled, right? Here c square, this part get cancelled, minus minus got cancelled. 2 by c is equal a plus b by ab. 2 by c is equal a plus b by ab. This implies 2 c is equal what? 2ab by a plus b. C is equal what? 2ab by a plus b belongs to a comma b. Cross multiply 2ab and this one c will go this side. That's it. Understand? Simple problem it is. Very, very important. So Lagrange Rolle's theorem, Lagrange's mean value theorem and Cauchy's mean value theorem. Okay. We'll solve another problem. One more problem. Okay. Next problem, verify Cauchy's mean value theorem for f of x is equal to e power x and g of x is equal to e power minus x in closed interval 3 comma 7. So f of x is what? E power x and g of x is equal to what? E power minus x. So what is the first point? F of x and g of x are continuous in closed interval 3 comma 7. Second point, f of x and g of x are derivable in open 3 comma 7. G dash of x differentiation is what? E power minus x differentiation minus e power minus x ma, not equal to 0. Minus e power minus x is not equal to 0. So therefore, then there exists c belongs to 3 comma 7 such that f dash of c by g dash of c is equal to f of b, f of 7 minus f of a means 3 by g of 7 minus g of 3. Correct? So what is f dash of c here? E power c. E power c differentiation is how much ma? E power c only minus g dash of c. E power minus c differentiation is what? Minus e power minus c. F of 7 is how much? E power 7 minus f of 3 is how much? E power 3 by e power minus 7 minus e power minus 3. Correct? So this can be simplified, e power 7 minus e cube by 1 by e power 7 minus 1 by e cube. So if I take minus common on the numerator, e power 3 minus e power 7 by, if I take LCM here, e power 7 into e cube, e power 3 minus e power 7. Correct? So this part got cancelled, this minus got cancelled. This will go to numerator, e power c into e power c is how much ma? e power 2c. Here bases are same, powers can be added, e power 10. E got cancelled. 2c is equal to 10, c is equal to 5, belongs to 3 comma 7. Understand? Like this you need to solve this Cauchy's mean value theorem. Okay, so these are the problems on Cauchy's mean value theorem. So we will do more problems, more previous year problems in the next video, right? Thank you.